Hello. Lovely little geometry problem today. We've got three squares, one with an area of 27, one of 12, one of 3, all stacked on top of each other. Another little 12 on this side. And then we've got this big one here, which you can see is leaning against our tower on the right and kind of balanced as well on the little one on the left-hand side. We want to find the area of this big red square. One important fact to note, this blue and pink line here, they are lined up with each other. So the blue one's not hanging over the edge and the pink one's not got any little ledge that it has on the top there. So first thing we can do is go through and find the side lengths of all of our squares over here. So looking at the green one, we have 3 as an area, so the side length is going to be the square root of 3. Similarly for the blue one, we have 12 as an area, so we'll have the square root of 12. Thinking about 12, we can write that as 4 times 3. So the square root, you can think about the square root of 4 times 3. We can then split that up into the square root of 4 times by the square root of 3. And the square root of 4, hopefully that you know, is going to be 2. So the side length for this blue one is 2 times the square root of 3. We can do a very similar thing with the pink one. 27 is 9 times 3. So imagine up here, if we replace this 4 with a 9, this 4 with a 9, when we square root that, we'll get a 3. So the side length for the pink one is going to be 3 times the square root of 3. Now then what we can do is try and think about this triangle and this big triangle here. So firstly, when we think about, we know this blue side already, and we know that this doesn't overhang at all. So where we have this blue side, it must be the same as this blue side because it's a square. The pink one is 3 root 3 long. The blue one is 2 root 3 long. So this little gap in here must be just 1 root 3 long. So when we think about this triangle, we've got one side length of root 3, one side length of 2 root 3. So we can use that to work out this length x, which runs not the entire length of the square, the red square, but just from this point here to this point up here. To do that, we use Pythagoras. So we'll get that the root 3, we need to square that. We can add that to the 2 root 3, that will also square, and that will be equal to that x squared. Root 3 squared gives us a 3. 2 root 3 squared would give us a 2 squared, which is 4, times a 3, so i.e. a 12 altogether. And we add those two up, we will get 15, which we can then square root to give us the square root of 15. So now then, we can use the little triangle to infer information about the bigger triangle over here. Firstly, we can think about the fact that we have this green line and this blue line. They're both vertical, so they are parallel, and they're both connected to this red line. So we can use the fact about corresponding angles to see that the two angles at the top here, one up here and one here, are both going to be identical to each other. So thinking about this, we have kind of color code them. These two are identical. We can use then exactly the same logic with this flat side, this horizontal line, and this horizontal line. Again, connect to the same red line over here to see that these two angles must be identical as well. So again, we'll denote those on there. What that tells us then is that this little triangle in here is similar to the big triangle that we can draw over there. So we can use that to think about how much bigger is the big triangle than the small one. Well, we know the height of this one was 2 root 3. And this big one is going to be the height of all the 3 squares that we have. So we've got 1 root 3, 2 root 3, and 3 root 3, all together giving us 6 root 3. How many times bigger is 6 root 3 than 2 root 3? It's 3 times bigger. So where we had x for this side length here, this little part of it, the actual side length of the entire square is going to be equal to 3x. We know that x itself was root 15, so 3x is going to be 3 times by root 15. And then we can just use the area of a square formula. I think we need to do that 3 root 15, all squared to get the area. So 3 squared is 9, root 15 squared is 15, and then 9 times 15 is 135. Lovely jubbly.